Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Mo's Algebra 2 class. Today we're going to start the beginning of the last section of Chapter 8, dealing with rational expressions. And today we're going to move on from rational expressions to actually solving rational equations. The good news, if you guys have learned how to simplify rational expressions thus far, in specific, if you know method 2 of simplifying complex fractions, remember how you multiplied the grand LCD to every single term? If you've got that down pat, this is a joke lesson. If you do not, it's still a joke lesson, but you're going to have to work a little bit more. You're going to have to review those prior skills. So hopefully this is a very smooth transition for y'all. A rational equation, similar to a rational expression, contains at least one rational expression. That means that it contains one fraction where there is a variable somewhere in the denominator. Okay? You can simplify solving a rational equation by literally eliminating the denominators. You can eliminate the denominators by simply multiplying the LCM, or in this case it'd be LCD really, because it's the least common denominator, of the rational expression to both sides of the equation. Performing these operations can lead to extraneous solutions though. Remember what extraneous solutions are when we were talking about absolute values. Extraneous solutions are solutions that you're going to get, but they may not necessarily work. So you have to test them out. All answers must be checked for accuracy. Okay? So this isn't you should do it. This is a you have to check for extraneous solutions. Okay, now, just gave you two little examples here. A rational equation right here on the left. I have variables in the denominator, okay? And then not a rational equation. This is just a one variable equation. There's fractions, but there are not any variables in the denominator. Now, before you get stressed out and before you freak out on me, let me just go back in time. If I wanted to solve for x here, for this particular equation right here, my brothers, I have denominators. Nobody, even me, who I really enjoy working with fractions, if I can, I will avoid fractions. I'm really good at them, you know I am, doesn't scare me, but still, if I can avoid it, I'm going to avoid it. So how can I get rid of the denominators here, gentlemen? Yes, sir, my brother. Very good. You're going to find the LCD, which is 6, and you're going to multiply every single term by 6. So that means you multiply it to here, to this term, and to this term. 6 times x is 6x. X times 1/2 is 3. And 6 times 2/3 is 12 over 3, which is 4. Subtract 3 to both sides. 6x equals 1. Divide by 6. X equals 1/6. And that's it. You're done. That exact procedure, what I just finished doing today, I promise you, I swear to you, is exactly the same procedure we're going to use to solve these. The only difference, the LCDs are going to be a lot more complicated because they're going to be polynomials. But the skill is the same. Find the LCD. Excuse me. Find the LCD. Distribute the LCD to every single term. Eliminate the denominators. And then solve. Now, when you solve, you may have to factor. You may have to use a lot of other skills that we've learned already. But the procedure is exactly the same. So let's get to it. Solve each of the following rational equations. As you can see, there's no steps here. No, there's no steps here. I already went over the steps. Find the LCD, distribute the LCD, eliminate the denominators, and solve. So step 1, find the LCD. What's the LCD here, gentlemen? Okay, for those of you who actually multiplied it together, please go back in time, go to your notes, and learn how to find the LCD. Thank you, sir. That's exactly correct. It's 3b times 2b minus 1. That's the LCD. I'm pretty sure we've gone over that, but just in case, you may want to have to go back in time and do that on your own again, guys. Okay? Now, what am I going to multiply? Step 2. Actually, let's do it like this. This is step 1. Find the LCD. Step 2. Multiply the LCD to every single thing. So I'm going to multiply 3b times 2b minus 1 to every single term. When I multiply 3b times 2b minus 1 over times 3 over 2b minus 1, which ones cancel here? What's left over here? So I've got 3 times 3b, goodbye denominator, equals, when I multiply this to 4 over 3b, who cancels? What am I left with, my brothers? So I've got 4 times 2b minus 1. Be honest with me. That's not too bad, is it? Not at all. Follow procedures. Now, step 3. Solve. That's it. So I got 9b equals 8b minus 4. Subtract 8b to both sides. And b equals negative 4. I am not done, unfortunately. Unfortunately, I am not done. I must test. So 3 over b is negative 4, that's negative 8, minus 3, that's negative 9. Thank you, Papa. And then this is going to be 4 over negative 12. This reduces to negative 1/3. Negative 4/12 reduces to negative 1/3. It works. That's my answer. Questions, my brothers, because it's going to get more complicated, but that's the procedure. You have my word. That is the procedure. Find the LCD. Distribute the LCD. Solve for the variable. What's that, my brother?
So all we're doing is just testing.
At the end, we're testing. Yes, sir. Correct, my brother. The only extra step is we got to test to make sure for any extraneous solutions. Thank you so much for caring. Yes, sir, my brother. Bam. I like it. 2 birds with 1 stone there. Any other questions here before I move on, my brothers? Okay. Now, number 2. Okay. We've got a little bit more of a complicated one here. In the first example, we couldn't factor out any denominators, but in this one you can. So the first thing we got to do is rewrite this. This is 4/3 plus 7 over x minus 4 equals x minus 1 over 3 times x minus 4. Now, what's my LCD, boys? There it is. 3 times x minus 4. Fantastic. Excellent job. Now, next step. We're going to multiply everything by the LCD of 3 times x minus 4. When I multiply it to 4/3, who goes bye-bye? Who's left over? So you got 4 times x minus 4. I know you went ahead and expanded it. I'm proud of you, but I'm just going to go step by step just to make sure. But thank you, sir. I'm proud of you. When you multiply it to 7 over x minus 4, what goes bye-bye? Who's left over? 7 times 3 equals, when I multiply to this last term over here, who goes bye-bye? What's left over? Nothing, x minus 1, that's it. Now, I can go ahead and distribute and solve. Some of you guys are going ahead and you're distributing this before, you're doing it in your head. That's fine, I'm proud of you. Be careful though. Writing down one little extra step is not going to waste time. But getting it wrong, having to erase everything and redoing it, that will waste time. Just food for thought. So this is 4x minus 16 plus 21 equals x minus 1. 4x plus 5 equals x minus 1. I'm going to subtract x to both sides. 3x plus 5 equals negative 1. Subtract 5 to both sides. 3x equals negative 6 divided by 3. X equals negative 2. I wish I could tell you we're done, but we're not. okay? We're really not. This is the part that a lot of people get lazy on, and this is the part where a lot of people get it wrong. You went through all of this work, but you're not going to check it. You're going to get hurt at the end. So this is 4/3 plus 7 over negative 6. Does that equal negative 3 over negative 6 minus 12 is negative 18? So is that correct? That's, yep. So this is reduces to 1/6. Okay, so let's see. This goes to 6, that goes to 8. 8/6 minus 7/6 is 1/6. Bingo. It works, it's good, and you're golden. Now, if you don't know how to add fractions, guys, you're going to have to go back in time. You're going to have to look at some videos and get those fractions. Yes, sir. Come again? This is a negative 6, yeah. So this is 8/6 minus 7/6. We've talked about this before. Thank you for your honesty, son. Whenever you have a negative attached to a fraction, it really belongs to the numerator. You can go negative 1/3. You can say negative 1/3 in the middle, or you could say 1 over negative 3. But all of those really equal negative 1/3. It's a negative 1 being multiplied to the quantity of 1/3. Sir, thank you for your honesty. Yes, sir. Yes, sir. 4x plus 5 equals x minus 1. Yes, sir. Because from here I gotta get rid of that x, right? I gotta solve for x. How do I get rid of a positive x? By subtract. Correct, sir. Correct, sir. Correct, sir. Thank you for clarifying, sir. God bless you. Good job. Any other questions before we move on, gentlemen? Thank you so much for your honesty. This would be the time to ask questions, gentlemen. Okay, we're going to move on. Thank you for those who asked. Whoa, Mr. Moore, what are you doing to us? I'm treating you like men, like juniors. This is what we do. It's real time now, okay? So let's go ahead and factor. So I got x squared plus 8x plus 6 over. We got to factor these denominators. The good news, this factors out real pretty. This is x plus 4 times x minus 1, which equals 3 over x minus 1 minus 2 over x plus 4. What is my LCD, boys? Yeah, I'll just write it here. So the LCD here is x plus 4 and x minus 1. All right? Okay. So now what we're going to do magic. Okay. Now we're going to multiply this LCD to every single term of the equation. When I multiply to this first guy right here, who cancels? The whole denominator, bye-bye, bye-bye. So I'm left with x squared plus 8x plus 6. Please do not factor because you got to solve still. When I multiply to this guy over here, who cancels? The x minus 1, what am I left with? 3 times x plus 4. Beautiful job. Excellent. And when I multiply this LCD to this bad boy over here, what do I get? Negative 2 times x minus 1. Does that make sense? May I continue? Thank you, brothers. So I've got x squared plus 8x plus 6 equals 3x plus 12 minus 2x plus 2. So I've got x squared plus 8x plus 6 equals 3x minus 2x is x. 12 plus 2 is 14. Now I got to solve. So I subtract x and I subtract 14 to both sides. Why do you do it to both sides, Mr. Moore? Why don't you bring the x squared over? Because whenever we're setting up a trinomial with a power of 2, quadratic, I want the leading coefficient of x squared to be positive. So this is x squared plus 7x minus 8 equals 0. Go ahead and factor x plus 8, x minus 1, 0 product property, x equals negative 8 and positive 1. Go ahead and write that down for a second. I'll pause the video for a second so you can write it down, and then we will check the answer. Okay, thank you guys. I had a couple good questions which I do want to go over. Question number 1. Mr. Morrow, do you want us to factor out the numerator? Well, first of all, it's not what Mr. Morrow wants, it's what math wants. Math does not want you to factor that. Think about it, guys. If you were to factor that, that would become x plus 4. Actually, that's not even factorable. But let's just say it was factorable. You're going to break up a polynomial, a trinomial, into 2 binomials that you're going to have to multiply again to solve later. Doesn't make sense. You don't factor anything except for the denominators. So you can find an LCD. Okay? Now, we got to check for extraneous. Before we get crazy, though, don't I have a denominator here of x minus 1? And I have a denominator here of x plus 4, right? So if we go back in time, we talked about recognizing values of x that are undefined, values of x that cannot exist in certain equations. Whenever you have an x in a denominator, that x cannot equal 0. That value cannot equal 0. So if I have an x minus 1 in the denominator and an x plus 4 in the denominator, we know right off the bat that x cannot equal 1 or negative 4. It cannot equal that. If x equals 1 or negative 4, I'm going to have a 0 in the denominator. That will render this undefined. So right off the bat here, oh, wait a second. I got x equals 1. That cannot work. It will not work. So you don't even have to test that one. Because when I plug 1 into here, 1 minus 1 is 0, and that's bad. Now, I do have to test, though, the negative 8. I have to. So let's test the negative 8. So I've got 64 minus 64 plus 6 over 64 plus 24 minus 4. Does that equal 3 over negative 9 minus 2 over, this is negative 8, so 2 over negative 4. Well, we're going to have to do some math here. Luckily, these two cancel, so that's 6, and then that's 88 minus 4, which is 84. I can divide both of these by 6, giving me 1 over 14. Okay, let's see if this equals this. I've got negative 3/9, which is negative 1/3. And that's a negative 4 down here, right? So plus 1/2. Come again? Wait. 64. Over here. Yeah. We got 64 minus, thank you. Thank you. 64 minus 24, you're right, minus 4, thank you. So that's 40, so that's 36? Okay, so 6 over 36, thank you guys. So that's 1/6. Now here, I got negative 1/3 plus 1/2. This goes to 6, that goes to 3, that goes to 6, that goes to negative 2. Hey, lo and behold, it does equal 1/6. Bingo, it works. My only answer here is negative 8. Very important for you to check. However, odds are, just so you guys know, odds are, not always, but odds are, if one of the examples is extraneous, the other one usually works. But I have had situations, and you will too, where you have no solution. So you got to check your work. Does that make sense? Okay. Next. First things first, let's factor. Does that mean I factor the numerator? No. Thank you. So this is 6 over x minus 4 plus 3 over x minus 2 equals x squared minus x minus 2 over, thank you, my brother, x minus 4 and x minus 2. Excellent. What's my LCD? X minus 4 times x minus 2. Awesome. When I multiply to this guy, what am I left with? 6 times x minus 2 because the x minus 4 goes bye-bye. When I multiply it to this guy, what do I get? 3 times x minus 4 because the x minus 2 goes bye-bye. And when I multiply to this bad boy over here, the whole denominator goes bye-bye, and I got x squared minus x minus 2. Let's solve. So this is 6x minus 12 plus 3x minus 12 equals x squared minus x minus 2. 6x and 3x is 9x minus 24 equals x squared minus x minus 2. Subtract the 9x, add the 24. Subtract the 9x, add the 24. 0 equals x squared minus 10x plus 22. No, it's not that it's a no solution. No, it's plus 22. You got 6x minus 12, yeah. 3x minus 12, yeah. That's negative 24. Okay, this is what happened here. This was my fault. I didn't make this factorable. That is my fault. This situation, guys, you have to use what's called the quadratic equation. We have not learned that yet. So, this is what's going to happen. If you get to this situation where you cannot solve it by factoring, because we just haven't learned that skill yet, I'm not going to hurt you. Just go ahead and leave that as the answer. On the test and quiz, trust me, I'll double check them all to make sure that it is factorable. But if you get to a situation where you get to your trinomial and you cannot factor it, leave it like that. What will you check, Mr. Morrow? That you got the correct trinomial here. That this is in the correct form. If you cannot factor it. But I'm going to do my best to make sure that it's all factorable on the quiz or test. Cool? We good? Okay. Let's continue. Okay. Let's do some more. Okay, this one should be easy. What's the LCD here? So what am I going to multiply everything by? By the LCD. When I go here, what am I left with? X minus 1, bye-bye. When I go over here, what am I left with? Cancels out, so I got x squared plus 2x minus 3. Subtract the x, add the 1. Subtract the x, add the 1. So I got 0 equals x squared plus x minus 2. Go ahead and factor. X plus 2, x minus 1, 0 product property, x equals negative 2 and positive 1. But wait a second, it can't be negative 2, so automatically you know it's going to be x equals 1. Okay? And if you want to check it, we can. 1 minus 1 is 0 over 3, so that equals 0. So 1 squared is 1. 1 plus 2 is 3. 3 minus 3 is 0, so I also get 0 over 3 here. Fuagada, it works. When you have one that's extraneous right off the bat, 99% of the time, the other one's going to be the solution. Yes, sir. I would say always check it. In this case, if you know that one of them is gone and you have time to do it, do it. You know, if you're crunched for time, at least you know you're going to get the fact that negative 2 is not a solution, correct? You know, so it's a matter of time management, but I would check it. I will get into the habit of checking it. Sir, thank you, my brother. Okay, here, what's the LCD? X plus 2 and x minus 2. So when I multiply it over here, what am I left with? 2 times x minus 2, because the x plus 2 cancels. When I multiply it over here, what am I left with? X times x plus 2, because the x minus 2 cancels. And over here, What do I do? What am I left with? X plus 2x minus 2. But that's a difference of squares. But yeah, let me not go ahead. Let me do it the right way. Okay, now let's simplify. 2x minus 4 plus x squared plus 2x equals x squared minus 4. Guys, at this stage of the game, I'm not going to do the longhand here. You either know the format for the difference of squares. If you don't, learn it, please. So this is 4x minus 4 plus x squared equals x squared minus 4. The x squareds will cancel. I add 4 to both sides. 4x equals 0. Divide by 4. X equals 0. What? Can that work? Let's check. Let's check. Wait, don't say no first, guys. Let's check. Don't assume. Check. So I've got 2 over 2 plus 0 over negative 2. Does that equal 1? What does 2 over 2 equal? 1. What does 0 over negative 2 equal? Does 1 plus 0 equal 1? So yes, it does work. So for all of you guys that immediately said no, please do not do that. You must check. You must check. You have to, please. Okay? Does that make sense, gentlemen? Okay, wait, go ahead, what's up? Okay, that's why we have a video. Next, let's rewrite this with factored form. X minus 1 over x plus 2, x plus 1. Excellent. Great. Plus 2x over x plus 2 equals x minus 1 over x plus 1. What is my LCD? X plus 1 and x plus 2. When I multiply that bad boy over here, what am I left with? X minus 1. Excellent. When I multiply this bad boy over here, what am I left with? Excellent. 2x times x plus 1, because the x plus 2's canceled. Both of these canceled there. And when I multiply the LCD to this last term over here, what am I left with? X minus 1, x plus 1. Very good. Gentlemen, no. No. The x plus 1 goes bye-bye. It's x minus 1 times x plus 2. Excellent. So I've got x minus 1 equal, come on, Moro, x minus 1 plus 2x squared plus 2x equals x squared. That's 2x minus 1, so x minus 2. Let's clean this up. I got 2x squared plus 3x minus 1 equals x squared plus x minus 2. Add the 2, subtract the x squared. So I subtract the x squared, I subtract an x, and I add a 2. I'm left with x squared plus 2x plus 1 equals 0. This is a perfect square. X plus 1 equals 0. X equals negative 1. Can that work? No. So this is no solution. It's extraneous. There are no other solutions. So this is no solution. Okay? Now, you may wonder, oh, Mr. Mo, we didn't finish number 8, and we didn't finish these over here. No, I did not. Do them on your own. You've got this. Do them on your own. First thing we'll do tomorrow, before the review, we'll go over these notes, make sure you understood that. Then we'll do the homework. May God bless you. Have a great day. Hope you learned a lot. Thank you. Bye-bye.